Let's take a look at how .NET works. Now, in this go-round here, I want to give you a 30,000-foot view of .NET. And what I want you to do is get a mental picture of how this is working, the 3 or 4 main steps, and then we'll talk about some extra things that you need to know about. But a very simple diagram here. In the old environment, when we wrote an application, say with Visual Basic 6.0, we created a form, and on this form we put code, and this code created a program that ran based on events. These are things that the user does where they click, whether they single or double click or that sort of thing. And once we finished writing our code and got it all functioning the way we wanted to, then we basically built a compiled code, and that is what actually ran on the machine. Now, .NET has a drastic change here. Once we compile our code, it gets compiled not to a regular machine language code. It gets compiled down to something called Microsoft Intermediate Language Code. Now, Intermediate Language Code is the basis for the whole idea with .NET, because from the Intermediate Language Code, it then goes and is turned into machine level code that runs on the CPU of the architecture that we're using. Now, there's a couple of interesting things right here. First of all, the MSIL, you'll hear this called a lot of different things out there. You'll hear it called IL code or I code or pseudocode and just all kinds of things. But the intermediate language is what makes .NET be so powerful. Now, if this looks a lot like Java, there's a good reason. This is basically what Java was trying to do, but it takes it a step further. And that further step is called JIT, or just-in-time activation. What happens with MSIL code? Once we write our code here, and it goes to MSIL, let's say that these 3 lines right here are a function or a procedure. Now, when it's ready to be compiled to be used on the CPU, then .NET grabs this function and compiles it down. Now notice this code right here does not get compiled until it's needed. Now once it's compiled, and future calls to that code cause it to run. So it doesn't have to be recompiled, it just runs without recompilation. Now this is a drastic difference from Java, where Java would grab all of this and compile it, and it made it a little bit slow. This uses just-in-time activation, or JIT. It activates just what it needs when it needs it. There's another thing that's real interesting about MSIL, and this is fundamental to .NET. If this code up here is written in VB or C# or any other code supported by .NET, which there are 20 of them, there's a lot of them out there and more coming, all of those get taken to the MSIL level. That means that regardless of how you write it up here, and there can be some serious syntax differences between these codes, it will be compiled into a nearly identical MSIL code down here. Because that's exactly what this guy does. He creates a like environment to be then compiled to run on the CPU. Now again, Microsoft's idea with this is that any CPU can run this code. Now right now only the Wintel platform is supported, but there are more coming. So the day's going to come that you can write your code in whatever language you would like here, and you can run it on any CPU that's supported by .NET. And as those grow, this thing's going to become a lot more universal. Now that's pretty huge, but there's another aspect of .NET that you need to be aware of, and that is the Common Language Runtime. This whole process, this whole family of technology and actions is governed by the Common Language Runtime. Now, the Common Language Runtime is, think of it as a policeman who watches this whole process happen. The Common Language Runtime governs the data types used up here in our code. For example, integers. It makes sure that an integer in VB means the same thing as an integer in C#. Now, some of these things may appear to us to be different. We may use a certain kind of integer here, and it may be named a little bit differently in C#, but it will compile down in MSIL to be the same thing. So first of all, it gives us a common data type. We don't have data type issues. Or it's called type safe. Our objects are also safe as well. It takes care of things like garbage collection. Now, in languages like C, in the past, programmers have had to walk a tightrope sometimes because it got rather expensive to build objects and then turn around and destroy them very quickly. And that's because of the way memory was managed there. When we take our software and we create a software object out here in RAM and manipulate it, once we no longer use this thing, we just break our connection with the object, and the common language runtime at some point in the future will automatically kill that thing for us. And we don't have to worry with that anymore. So it's made it a lot more efficient. Now, here's the thing with .NET. You've just seen the basics, how it works, how it's thinking. The task for you now is to get your hands around this. You will spend 99.9% of your time right here, just like you always have. This is some cool stuff down here, MSIL and Common Language Runtime, but it's not going to involve you a whole lot. These things tend to run in the background. You need to go out and get in the documentation that comes when you install the .NET framework. Look at that documentation, or the SDK rather. When you install the SDK, you get the documentation. Begin to read through that. I mentioned in the previous video, a few videos back, there are over 8,000 classes that you can work with here. You got a lot to learn, but understand this is a really cool idea, and the thing works. There's your 30,000-foot view. Take this and build the rest of the information from these videos on this, and I hope this will help clear it up and keep you in step.